Hi team, it's 10 o'clock and as you can see I'm at 0% on this assignment. I'm going to pause the video, complete the assignment, and let's see how I do. Okay, so let's take a look. I did have two people come in and talk to me during this time. 21 minutes to finish this assignment. And I found these two sections very long. So I'm going to trim the numbers there for you immediately. And then I'm going to come back and do a walkthrough, continue the walkthrough. All right, team, so let's carry on here. One thing I should point out is when you have your D2L going, oh my goodness. So as I was saying, when you set up to do your delta math, you want to have a calculator handy and you want to have some scratch paper handy. So I have my scratch paper over here. So let's clear that and I'll show you some fresh questions. We're going to go through line by line. So polynomial vocabulary is something we looked at a little bit. Now there are a few words here that I don't tend to use, but that we'll learn from delta math. Okay, this expression here, it represents and there's different types of polynomials. The different types have to do with the highest degree term. A linear polynomial, I'll show you some examples over here, and we'll make this a little smaller. Okay, here we go. So we have a few options. Let's see if I can open them, and then, no, I can't. All right, so a linear polynomial. Here we go, Mr. Jennings. Linear, this would be something like x plus 5. Okay, it's a binomial, and its biggest term has an x exponent to the 1, okay, which we don't write. Quadratics, this is grade 10. You will see x squareds, then it's a quadratic. You just need to look at the highest degree polynomial and then you'll know. Cubics, these are all words we talked about in class. C-U-B-I-C-S. My goodness, Mr. Jennings. Here we go. Cubic will have x's to the 3, and they could be 4-term polynomials. They could have 4 terms. They could be like x to the 3 plus 2, x to the 2 plus x minus 5. And this could have like a 3 on the front, 3x to the 3, etc., etc. That would be a cubic polynomial. And then there's 2 more words, quartic and quintic. Okay, so quartic has the quar, like the qua, the quartic. These will have x to the 4 somewhere in them. And a quintic, like a quintuplet, will have an x to the 5. Okay, so that's how you can distinguish between the different types of polynomials. So this one represents a quartic polynomial with how many terms? Count them. 1, 2, 3. There's 3 terms linked by subtraction here. The constant term, we want to be able to identify this term here as the constant term. The constant term is minus 1. The leading term is the first term of it, 9x to the 4. Okay? And the leading coefficient, well, that's this number here. The number that multiplies the variable in the leading term is the leading coefficient, and that would be 9. So let's submit that answer. Yes, correct. Okay, let's look at another one. Here is one that has a funky first term. This is a quadratic. It has an x squared, so it's a quadratic. It has 2 terms. The constant term is negative 1. Don't forget the sign. The leading term is 1 over 7 x to the 2. And the leading coefficient is 1 over 7. Okay, let's look at this one. This one's good. This represents a quintic. It has an x to the 5. It is 3 terms. The constant term is 1 over 2. It's positive 1 over 2. The leading term is x to the 5. Okay, so this is the leading term. The leading term is the term that has the highest degree x variable. The leading coefficient is 1. 1. So this is the tricky type question here. There's a cheeky 1 that's hiding there. It's 1 multiplied by x to the 5. Submit answer and you'll see that I am correct. Okay, there we go. So that's how you will answer those. Now, rewriting polynomials in standard form is just changing the order that these terms appear. Here, we want to have the polynomial written from highest degree down. So let's go for it. We would have x squared divided by 2 plus x minus 9 for this one. Just rearranging it so that that term is in the front. New problem. Here, our I don't know if I'm allowed to write 1 over 3 multiplied by x squared. Maybe it wants me to do x squared on top, like x squared divided by 3, which would be the same thing. But let's try it this way. Minus x minus 2. Notice I've just taken these terms and rearranged them into descending order of exponents. The signs always follow the numbers, so minus 2 is minus 2 at the back. Let's say submit answer, enter, and it likes that just fine. Okay, so that's all you need to do for those. Now, adding and subtracting polynomials is, again, collecting like terms. It's more work on collecting like terms. So let's go ahead and do some of that together. Here we go. First thing that I might do is copy out the question onto my scrap paper. If you have beautiful digital paper like I have, you can copy it this way. Isn't that nice? Get yourself one. It's super fun when things work. There we go. I want it a little bigger. And so now here's what I do. I say, well, I'm going to write another line. And my next line is going to start with an equal sign, because what I write here is going to be equal to what's above. 9x squared plus 7x minus 6. I can open up those brackets. There's nothing I can do inside them. There's nothing being done outside them. But then I need to subtract all of this stuff. So I'm going to subtract 3x squared, and I'm going to subtract negative 8x. Subtracting a negative is a positive. So that's the thing that I really wanted you to focus on. Here, subtract that. It means flip the signs. I flip the sign here, I flip the sign here, and I flip the sign here, minus 7. Why? Because I am subtracting this polynomial from the other stuff. So that's why all that gets, all the signs inside the brackets flip. Now I can collect my like terms. 9x squared minus 3x squared is 6x squared. 7x plus 8x is plus 15x. And minus 6 minus 7 is minus 13. Let's put that in and see what Delta Math thinks of that. Oops, minus 13. Hooray! Okay, let's do one more. So you can see adding and subtracting polynomials. Actually, there's another problem type that I want you to see. But here I'll show you that I can do this one without some scratch paper. I see that there's only one x squared term, so that's 10x squared. Minus x minus 9x would give me minus 10x. And then plus 1 minus minus 2. Minus minus 2 is now plus 2. 2 plus 1 is 3. So this will be plus 3. That's how you do those. Let's see if I get one of these. No, let's do new problem. Aha. So subtract this from this. So let's take a look at how we want to write this. I'm going to start with the one that I'm subtracting from. Minus 6x plus 5. And then I'm going to subtract, put it in brackets, x squared minus 2x minus 6. Okay? Remove the bracket by expanding this negative in there using the distributive property. Okay, so minus 6x plus 5, flip all the signs inside. Minus x squared plus 2x plus 6, collect like terms. We will have negative x squared minus 4x plus 11. Put that in there. Well, minus x squared minus 4x plus 11. Let's keep going. Two-step equations. So here, you look at it and you say, well, that would be 13. A is negative 13. But maybe you can't look at them and solve them. So what you need to do is write them out and then use your inverse operations. Okay? So these work just like mobile problems, all right? Minus 50 is equal to 6 multiplied by some number plus 28. Okay? Now, what I do is I say that 28 over there is annoying. I'm going to remove it. I'm going to subtract 28 from both sides. Then I get this line. Minus 50 minus 28 is minus 78 is equal to 6a. And then I say, well, I'm multiplying here. That's annoying. I do the opposite of multiplication, which is division. Negative 78 divided by 6 is negative 13. And this 6 cancels that 6, so I'm just left with A. There's the answer. Okay, here, I was adding to my variable. So I do the opposite, which is subtraction, but I have to do it to both sides. I was multiplying my variable, so I do the opposite to both sides, which is division. And that's how you get to the answer minus 13. Hooray, let's do another. Here, I add 1 to both sides to clear that minus 1. So that gives me 12 over there. 12 is equal to negative c over 2. Well, c can be negative 24. All right, I'm going to multiply both sides by negative 2 because here I'm dividing by negative 2. And when I multiply 12 by negative 2, I get negative 24. Okay? So you see, those are actually how I do it in my head. I do the steps in my head, but because I have a lot of practice, I can do that. Here, it's going to be minus 6. So watch. Negative 6y minus 31 equals 5. It's annoying that I'm adding to my variable, so I'm subtracting from my variable, so I'm going to do the opposite, which is add. I'm going to add 31 to both sides. That will give me negative 6y is equal to 36. And then I divide both sides by negative 6. 36 divided by negative 6 is negative 6. There's my answer. Hooray! So that's how you do these. Inverse operations, it's called. Two-steps equations with decimals. These ones, you need your calculator and you need your scratch paper. So here, but it works the same. So right now, I would like to clear away. Actually, I could clear away all the negatives. Here's a trick I could use. I can multiply both sides of this equation by negative 1. This is what I would get. 1.95 is equal to 1.7. That's a point there. Plus c over 0.4. Okay. I just flipped all the signs on both sides. There's another thing you're allowed to do. It's the same thing as multiplying both sides of the equation by negative 1. Okay. Clears all the negatives. All right. Now, I am annoyed that I'm adding 1.7 on this side, so I'm going to subtract 1.7 from both sides. Okay, so now I will get 1.25 over there. 1.9, this is 1.25. Sorry, it is not. It is 0.25 is equal to c over 0.4. It's lunchtime. Now I multiply both sides by 0.4. And so what's 0.4 times 0.25? May nobody bothered to. I think it's 0.001. I think it's 0.01. Okay, let's try. 0.4 times 0.25 equals, 0.01. Yeah, okay. So C is 0.0, oh no, it's 0.1. 0.1. Hey, so that's how you do these. It's the same as the other ones. You've got decimals in them. So you probably need a calculator, more likely than not. Now, with fractional coefficients. I got a lot of distractions today. Okay, it's good to be distracted. No, it's not. All right, so here, this is the same, but now we have to do it with fractions. Okay, it's the same. So let's do it with fractions. Here, 11 over 12z. Let's do that so it doesn't look like a 2. Plus 6 equals 83. Subtract 6 from both sides because it's annoying that I'm adding 6 to my variable here. So then I get 11 over 12z. Plus 6 minus 6 is 0. 83 minus 6 will give me 77. Now, what I like to do here is multiply by the flipped fraction. Because what that does, when I multiply this will cancel that, and that'll cancel that, and it just leaves me that, which was my goal. But I have to do that to the same thing on both sides. So I multiply by 12 over 11. Now, let's take a look. We've got z is equal to 77 times 12 over 11. But I'm going to write 77 in a funky way. I'm going to write it as 7 times 11 multiplied by 12 divided by 11. 11 cancels 11. So I get 7 times 12 gives me 84. Yay! Okay. And make sure you say yay and pat yourself on the back when you get these right, okay? That's important. It's good to feel good. Now, this one here, these can be really fun. If you can start doing these in your head, it feels pretty cool. So let me try this one in my head. I subtract 24 from both sides, so I get 15 over there. 15 is equal to 5 over 7c, multiply by 7 over 5. So then I get c is 21. Yay! Okay, and let's check there. So they subtracted 24 from both sides, like I said. They get here. They do it in 2 steps. They multiply by the denominator. Cool. And then they get 105. I can't really do that in my head as easy. And then they divide by 5. I don't like doing that in my head. What I did was I multiplied at this stage by 7 over 5, which I know clears the fraction over there, leaves me c. So it's easy to do that in my head. And then I have 15 multiplied by 7 divided by 5. 15 divided by 5 is 3. 3 times 7 is 21. It's not that hard. Once you know your mathematical times tables and you can do these things, you can do these in your head. It's great practice if you can start doing those in your head. Now we get into some of the more challenging equations to solve. I don't ask you to do too many of each, but I have a wide variety of these. These ones aren't that bad. We just have to collect like terms on both sides. Okay? The strategy for these ones, the 3-step linear equations, is to get all of your x's to one side of the equation and all of your y's to the other side of the equation. Let's say you have boy bunnies and girl bunnies, and you don't want any more bunnies. You keep your boys separated from your girls, and you won't get more bunnies. Okay, this is math class, so I'm not going to go into more detail than that. But some people will ask me, which side should I put the x's on? Which side should I put the numbers on? You know what? Doesn't matter. Just get them on different sides, okay? If you put the male bunnies on the east side of the barn and the female bunnies on the west side of the barn, that's going to work. But if you flip that and put them each on the other side of the barn, still works, okay? It's just, where you have more of one maybe makes it easier one way or the other. So what I'm going to do is I'm going to move this 10x away. I'm going to move it over there, okay? And I'm going to move this 1 away. So I'm going to move it over there. Okay, so what I did was I moved all the numbers that way and all the x's that way. And that's going to work. I got my bunnies on different sides of the barn. All right, now 14x minus 10x gives me 4x. 1 minus 1 gives me 0. 10x minus 10x gives me 0. Negative 19 minus another 1 gives me minus 20. Then I divide both sides by 4 to find that x is negative 5. Hooray! Okay, so that's that level. I'll show you the next level right away. Here is, that was 3 steps. This is linear equations of distribution. All right, so now we got to distribute the 7 in before we figure out that, there's 35. Why do I love to do them in my head so much? It's 56. Y is 8. Okay, so here's how I do that. 7 times y minus 5 equals 21. Okay, first thing that I have to do is I need to, what I want to be clear on is what I'm trying to find, which is the value of y that makes this true. Okay, this is one equation, one variable, so there's only like one value that it can be, unless we start doing fancy things. We're not going to do that. So what we do first is we take the 7 and we multiply it into the bracket. But we remember that that's like 7 drawers of clothes, and we have the same amount in every. So that's 7y minus 35. That 35 came from 7 times negative 5, okay? You have to multiply both of the terms in there is equal to 21. Now we can do our inverse operations. Add 35 to both sides. And then we get 7y plus 0 is equal to 21 plus 35 is 56. Now we divide both sides by 7 because we were multiplying here. So we divide, this 7 cancels that 7, this is equal to 8. 8! Yes. Let's do one more. So now we have 7 times 2y minus 8 is equal to 14. That's interesting. That sounds pretty cool. Okay, so 7 times 2y is 14y. 7 times negative 8 is minus 56 is equal to 14. Add 56 to both sides. Gives us 70. And 14 times some number equals 70. Well, that's 5. Okay, why? When I divide these by 14, you'll find 70 divided by 14 is 5. Yay. If I look bored, I'm not bored. This is fun for me. Okay, so let's do a level 2 distribution one. Oh, we got more like terms to collect. Please, Mr. Jennings, can we have more of these problems? These are great problems. All right, first we start by copying it out. 3x plus 5 plus 3x. Notice I can copy it by hand faster than I can with copy-paste. Okay, now, first I have to do BEDMAS first, and then you can solve it, okay? So here is multiplication, here is addition. Which one do you think I should do first? Of course, the multiplication. Multiply this in. Okay, so that's 3x plus 15 plus 3x plus 1 equals negative 32. Okay, so 3x plus 3x is 6x. 15 plus 1 is 16. Collect like terms, okay? Here is an x, here is an x. They combine to 6x. Here is a number, here is a number. They combine 15 plus 1, last time I checked was 16, equals negative 32. Subtract 16 from both sides. Gives me this is minus 48. 6x equals negative 48. Well, x is negative 8. Yay. Okay, so I divided both sides by 6, and that gave me negative 8. So that's how you do that level. Fractional linear equations. Oh, aren't you lucky you get to practice your fractions today? It's so great. Okay, these you can distribute in just the same way, but I'll show you a trick. I'll show you this one 2 ways. This is, okay, I'm just going to do this as though it was one of the other questions. First thing that I do is distribute this quarter in. I have to multiply it by both spots. So then I get 3 is equal to 7 over 4x minus 1/4 times negative 16 is negative 4. Okay, I put negative 16 over 4 and then I reduce it to negative 4. Okay, now I add 4 to both sides and then I get 7. Oops, let's add 4, Mr. Jennings, not add 7. 7 is equal to 7 over 4 times x. So that tells me that x must be 4, but maybe you can't see it yet. So what you do is you multiply by the flipped fraction, 4 over 7. Multiply by 4 over 7. And then we have a 7 on top. That's 7 over 1. Those cancel, leave me, this cancels this, that cancels that. It leaves me x is equal to 4. Just believe me, man. 4. Yeah. Okay, let's look at another one. So that's I just do it stubbornly as though it's one of those problems. Let me show you a trick that I use for these ones. Okay, you're this far into the video, you deserve a trick. All right, you shortcuts. All right. So isn't the fraction annoying, everyone? I don't think it's annoying, but I do know a way that I can deal with it very easily. Multiply both sides of the equation by 4, right here. Okay, 4 times 1 happens to be 4 last time I checked. 1/4 times 4 is 1. Ah, isn't that nice? It's all just revealed itself, easy to solve now. See, 1/4 times 4, so that cancels that, okay? Now I subtract 8 from both sides to give me a negative 4 is equal to 2x. Divide both sides by 2 to get x is equal to negative 2. Okay, so don't you like that trick, everyone? You can multiply by that fraction. That's going to be really useful in these ones, I think it is. Yeah, these ones, it's really useful to do. Okay, otherwise these ones are super hard. No, they're not that bad, but they're okay. Let me just help you out with this one. Okay, this is the trick that I want you to have. X minus 1. These are the hardest questions I've asked you so far this year. And they're fun. And I was doing them, I think I was doing some in my head, and they're challenging in my head, but for you, I suggest trying them this way. Here, I noticed that 3 and 8, if I were to multiply both sides of the equation by 24, then both those fractions will go away. So let's multiply both sides by 24, okay? What I'm going to do is put this in brackets, and this in brackets, and I'm going to multiply both sides by 24. 24, okay? So then this is what I'm going to get. This is equal to negative 2 times 24, negative 48, okay, on that side. 24 distributes in. It multiplies this term and it multiplies this term. Okay? All right? And even better, put brackets here and brackets here. All right? So 24 over 3 is 8. 24 divided by 3 is 8. So I will have 8 times x minus 1. Okay? I didn't choose to write down 24 over 3, which is just 8. I chose to write down 8. Okay? Plus 24 over 8, well, that's 3. 3 over x plus 5. Okay? All right? Now I distribute these in. So I get 8x minus 8 plus 3x plus 15 equals negative 48. Now I collect like terms. So I have 11x plus 7 equals negative 48. And then I subtract 7 from both sides to give me 48 minus 7 would be minus 55. Ah, there's my factor 11. Isn't this a beautiful problem? 11x equals minus 55. Divide both sides by 11. X is equal to negative 5. And then you can, of course, substitute it in here and check. Negative 5 minus 1 is negative 6. Negative 6 divided by 3 is negative 2. Negative 5 plus 5 is 0. So this is 0. So negative 2 equals negative 2. Negative 5 works. Yay! Okay, I think I only asked you to do one of those. 2! Oh, wow! This one I asked you only do one. Okay, all right, this one. Let's try this one. Okay, so 3 over 2 multiplied by 4x minus 1 plus 8x is equal to negative 4x. I need more paper. My goodness. I can shrink it. There. Plus 4x. Okay, collect all your like terms and do all your distributions. Okay, do it in Bedmas order. So first do your distributions. 3 over 2 times 4 gives me 12 over 2, which is another way of saying 6. 6x minus 3 over 2 plus 8x equals negative 4x minus 1 over 2 plus 4x. Well, that's convenient. Plus 4x minus 4x is 0. Okay, so let's send the first we're going to collect our like terms on this side. I did already collect my like terms on that side, but I had 4 apples and I took away 4 apples. Okay, it's 0 apples. All right, 8x plus 6x. Okay, so we're going to combine these terms into 14x. And then we're going to, come on in, and then we're going to add 3 over 2 to both sides. And these will collect here, okay? They'll collect to 1. So I have 14x is equal to, because this goes to 0, right? So I just have 14x on that side, is equal to negative a half plus 3 halves. So negative 1 plus 3 is 2, so that's equal to 1. And so I have x is equal to 1 over 14 when I divide everything by 14 here. Okay, so this is 1 over 14 equals. Hooray! And only do one, so I only can do one for you. If you can't get it, if you can't get one to go, move on. Okay, just do the other problems. Know that those are hard. All right, simple proportions. These were on the test last time for rationals, okay? And here we go. This, I look at it and I say, well, that's negative 25. And how do I do that? Okay, well, I say 3 over 5. Negative 3 over 5 is equal to 15 over x. But in my mind, what I do is I see this side as 3 times 5 over x is equal to negative 3 over 5. Or maybe I didn't say that this was, maybe I said that was plus 3 over negative 5, okay? And I see that this has a factor 3 over there. I need to multiply this by this factor 5, so I get negative 25, okay? But what you can do, if you want to work these out step by step, and so my preferred way for doing it in my head is different than working it out step by step. Working it out step by step, I multiply both sides by x, so that I get negative 3x over here, and these x's cancel. So I basically brought the x from the bottom here to the top on the other side by multiplication. I multiplied both sides by x so that I have negative 3 over 5 times x equals 15. Now, I multiply by the flipped fraction. So I'm going to multiply by negative 5 over 3. Multiplied by negative 3 over 5. So I multiply by the same thing over here, negative 5 over 3. Okay, so now this all cancels away and goes to 1. So I have 1x is equal to 15 times negative 5, which is negative 75 divided by 3 is negative 25, okay? So just like I told you, that's the answer. Yeah. All right. So that's how you do those. Another strategy with these is to flip both sides of the equation. Okay. This is another trick. Okay. You got this far in the video, you want a trick. So here's your trick. Negative 2 over 11 equals 8 over x. Flip both sides of the equation. 11 over 2, but it's negative, equals x over 8. Multiply both sides by 8. Negative 88 over 2. Well, that's not very good. This can be 4 and that can be nothing. All right. Well, 1. This is 1. So this is negative 44. And that's not the way I do it in my head. I do it in my head in a different way. I'll do another one in my head to prove to you. Okay, this one is 20. The way I do that in my head is I look and I see that this fraction here has been scaled up by factor 5. So I just scale up the top by factor 5. Okay. Now, these ones, a little trickier. Okay. So let's do one together. Okay. Here, what I do is, again, I look for that number where when I multiply it, both sides of the equation, both fractions go away. That number in this case is 6. So 5x plus 4. Helpful to put these in brackets. They exist. The brackets do exist there. Multiply both sides by 6. Okay. And the reason I do that, let's actually multiply both sides by 3 times 2, which is multiplying by 6. Okay, I multiply both sides by 6. But this factor cancels that factor. This factor cancels that factor. That's why I chose 6, or 3 times 2. Okay, and then we multiply this in. Okay, use your distributive property to multiply that in. Use your distributive property to multiply that in. And then you get 10x plus 8, that's this distributed in, is equal to 3x plus 27. That's this distributed in. Then you subtract 3x from both sides and subtract 8 from both sides to get 7x equals 20. Equals 19. Oh, I thought I was going to get something nice. Maybe I've made an error somewhere. This will be 19. So x is 19 over 7. Let's try it, see if I've made a mistake somewhere. No, I didn't. Okay, so that's how you do those. Okay, everyone. So that was a walkthrough for today's Delta Math, and I hope that your math practice is fruitful. We need a secret code word of the day, and I think the secret code word of the day can have to do with Santa Claus. Okay, so the secret code word for today is Santa Claus. Email me Santa Claus in the subject line of an email, and then in the body of the email, tell me what you learned today. Did you learn how to solve linear proportions? Did you learn how to clear fractions out of your work so that you're just working with integers? Or did you learn that I'm a crazy guy who likes to make you do a wide variety of mathematical problems to solve for X or A or whatever? Hope your math practice is fruitful today. Bye for now, everyone. Definitely hit me up by email if you have any questions.